Yes, another medical equipment teardown. This time we got a HenMed baby warmer, 50 watts. We got this heating pad, or actually that's not a heating pad. This is just a test unit. And yes, well, let's have a look at it and see how it works. I don't have the actual pad, I didn't find it in the dumpster, so that was a bit sad. Got a resistance ohm meter here if we want to measure the resistance of the heating pad. But if you turn it on, it just screams. And we don't got any heating pad, and we don't got any temperature differential, and water. You're supposed to have water there? I have no idea. So yes, degrees up here, how hot it is, how hot the heating pad actually is. So yes, that screams away. Sounds really bad. Yes, we got on this test panel, we got testing of heating and calibrating. And yes, we got this heating pad. It looks like that, kind of. We put the baby on the heating pad because babies cannot regulate body heat so well. And we got this little knob here. Can fine tune the heating. Actually 40 degrees, that goes up here. And we can also do a over temperature test. So you don't want to cook the baby, you want just to warm it up a bit. So yes, let's take it apart and see how it works. It will be interesting. So yes, if I have a look on the back here, we got this earth tap that connect to the actual earth receptacle, with a special earth receptacle in the hospital that we are using. And we got some fuses. Often there are two fuses, one for a live and one for a neutral. And we got some warnings here. Disconnect mains before servicing and stuff like that. That's obvious. And it runs on 220 to 40 volts AC, 110 to 120 volts AC. But we can even use 12 or 24 volts DC. And we're actually using this connector on the bottom here. That goes to the testing panel. And yes, here we got battery 12, 24 volts. And this is the goes to actual heating pad, and that's the test wire as well that goes to this thing that I just showed you. And up here we got a selector switch. On the back here it even says that ground invariability can only be achieved when the equipment is connected to an equivalent receptacle marked hospital only or hospital grade. And they're of course meaning that ground tap here. Let's open it up. Here we go. This is how it looks inside. There's even an earth tap here. The plate. Let's remove that. The battery holder looks a bit small for 18650. They're not actually fitting there quite good. I think they're actually using just a normal rechargeable AA battery. Here's another view from the circuit board. We got an EEPROM here. We got some logic controller here. We got a bunch of digital chips, 2 relays, some regulators here. We'll have a better close-up on the circuit board later. We'll have to take it to bits. We got 2 that looks like transistors here. The wire goes to this battery 12 volt, 24 volt connector. We got I think that's a power intake from the transformer. We got a double diode rectification, so it's maybe center tapped transformer. With a fuse, we got a shunt resistor here, and this big connector here goes to the heater. And underneath here we got a large toroidal transformer. Yes, I almost missed it. Made in Sweden, and the IP class IPX1, and this is the medical sign that's safe for human use. So let's open it up like this. You can see the rather big selector switch and the filter, interference filter here. And look at that beautiful earth terminals here. Very nice. And if you take away the circuit board here, and there we've got the transformer. And this transformer is 224 volt, 115 to 230 volts in. So it's a very nice transformer made by Toroid and passed the test. Nice. Sadly, it doesn't say what the colors are, so I have to figure that out myself. Here's a display board. It doesn't contain so much, just a bunch of LEDs and some resistors. This wire goes to the push buttons on the front, got a buzzer. If we flip it around, there is nothing under here. So it's just surface mounted components. And this is actually a through-hole component, but it's actually soldered on directly here. That's how I can do it. And the LEDs just lights straight through the circuit board. I drilled nice holes for them. Here's the main circuit board. The power comes in here. We've got a double diode rectification because it's a center tap transformer. Not required the 4 diodes, just 2 diodes are good. We've got a reverse power diode here that prevents the power going out to the battery, I think. I think it's that way. This protects the battery for being like charged from this one, because this is not a battery charger, obviously. We've got some fuses, one for the battery here and one for the mains from the transformer. Got a 0.33 ohm shunt. Got a smoothing capacitor. This one is a 5 volt regulator and this is a 8 volt regulator. I've never heard of 8 volt regulator before. What do you use that voltage for? I have no clue. Yeah, 7808 CT, 8 volt regulator. And from the top here you can see 2 bipolar transistors that are connected in a Darlington configuration. This is to send a PWM signal to the heater, and that goes through this relay here. The other relay is for switching between battery or mains operation. And if you look down here near the transistors, we can see some pretty interesting component layout. Got a resistor underneath the capacitor here. So I soldered a capacitor directly on this resistor here instead of having it beside it. They maybe didn't have so much room for that. Same thing on the back here. But a pretty dodgy soldering there. That looks very bad. Have they maybe done that afterwards, maybe? That doesn't look good. Looks very bad. This one here looks much better. And on the side here, there's a port that goes to the connector for a display, LEDs. And here we've got 3 of these HC374. And these are octal flip-flops, so there are 8 flip-flops in that, and they're working in a sort of counter when they're connected like this, obviously I think. So it's maybe counting some steps how the actual heating procedure goes. Here we've got the main chip. We got this long number here, 1J84G, and I could hardly find any data sheet for that. I think it's maybe some kind of 4-bit, like not so fast processor with built-in crystal, because I don't see any crystals around it. How could I miss the crystal? It's right here. It's a 455 kilohertz crystal. I think we're ready with this unit here. Let's have a look on the tester. First of all, the tester got this long array of push buttons, and they're all mechanically connected together. So I push in one button here, it disconnects the first one. It goes like that. I think that's the largest switch that I've seen that are connected together like this. There are many switches. And I've got a Pretty high quality Cermet potentiometer. There's a 5-volt regulator. And here's a 74123AN, which is a retriggerable monostable multivibrator. So that's some kind of oscillator here. Got these capacitors and some resistors around it. And here we got, on the switches, we got some resistors. And parallel with them we got this black thing, which I think is some kind of precision resistor. And here we got a relay, a transistor that drives the relay here, and 2 LEDs, and that's more or less about it. Not so much actually here. Actually, I have to say something about this relay. It's pretty special. It's a 5-volt, and we got a bunch of different voltages here, that how much you can switch. If you flip it around, we can see that it got 4 pairs of contacts. We got the coil in the middle here, and we got 1 pair here, 1 here, 1 here, and 1 here. I've never seen such a big relay in a such small package with 4 contacts in it. Pretty special thing. And pretty high quality relay as well. And why they're actually using this kind of switches here, if you want to press this and test the power to 40 degrees Celsius, and if you actually want to measure the resistance, you can just push that in. You will get the resistance of the heater, and automatically this switch pops up like that, so you don't accidentally put like the voltage that goes to the heater to your multimeter here. That's a very good solution actually. Hope you found this video interesting. More medical equipment teardowns coming soon. Thanks for watching.